And we're back. This was fun. I will need to refresh my stream issue counter because I feel like restarting the stream will we'll take it back to 0. Right? Let me see. See? I put... Yeah. 0. For now. For now. Don't worry. It will go up pretty fast. Okay. Where were we? And why am I here? We were here. So. Hello. We are starting off with the tree interpreter. Obviously, this is the part where there was another stream before this. That's why it looks like I'm starting in the middle, because my internet cut off, I guess, in a way. And I need to refresh this. Oh, I did. I think I did, didn't I? I already did. No worries. We have a goldfish memory, and that's okay. There's a plugin for the or is there titles? Do we have titles? Where are the titles? Sure, collapse everything. Oh, nah. I want to see the titles. Forget about it. We were here. Great. Installing, and then us getting this, and then here we are splitting validation, and we have 2 data frames, and then we say row x valid values. So we're looking at the first row of values, right? Is it what's been... So this is 1919. I'm guessing this is when it was made. I don't know. But like, we're looking at one row, aren't we? And then prediction. We're saying, what does TI stand for here? Predict this row, and then we're looking at prediction, bias, and contribution. So we're looking at one row again. The prediction is what the target is based on our prediction. Oh, TI is a tree interpreter. Got it. Okay. And then out of that, we're getting the bias, which according to our instructor, he said it's the actual value of the target. And then contributions is what these little things contributed. So if we look at, we can see prediction and bias here. And if we look at the contributions, again, we're looking at one row as far as I can tell. We put it here. No, we just sorted it. I think we're looking at it here. I see a lot of minuses. It's sorted, that's why. And the biggest thing is year made, then coupler system. It's a nan. Well. And then the total of the contributions is the difference between prediction and bias. Isn't that cool? That's pretty cool. Whew, we're done with predictions. Next. From what I see, we won't be able to finish this lesson today. If the internet doesn't kill me, I'm pretty available for another hour-ish, but the internet might kill me. Let's see.
step we're going to do before we try and build our own random forest is deal with this tricky issue of extrapolation. So in this case, if we look at our tree, let's look at the accuracy of our most recent trees.
89?
We still have, a big difference between our validation score and our training score. Actually, in this case, it's not too bad. The difference between the OOB and the validation is actually pretty close. So if there was a big difference between validation and OOB, like I'd be very worried about that we've dealt with the temporal side of things correctly. Let's just have a look at, I think our most recent model, here it was. Yeah, so there's a tiny difference, right? And so on Kaggle, at least, you kind of need that last decimal place. In the real world, I'd probably stop here. But quite often you'll see there's a big difference between your validation score and your OOB score. And I want to show you how you would deal with that. Particularly because actually we know that the OOB should be a little worse because it's using less trees. So it gives me a sense that we should be able to do a little bit better. And so the reason, the way we...
Our OOB should be worse. Okay.
Should be able to do a little bit better is by handling the time component a little bit better. Here's the problem with random forests when it comes to extrapolation. When you've got a data set that's like, got 4 years of sales data in it, and you create your tree, right? And it says like, oh, if it's in some particular store and it's some particular item and it is on special, here's the average price, right? It actually tells us the average price, over the whole training set, which could be pretty old, right? And so when you then want to step forward to like, well, what's going to be the price next month? It's never seen next month, and whereas with a kind of a linear model, it can find a relationship between time and price, where even though we only had this much data, when you then...
That's actually true. You can't really show time in trees, can you? You could. I feel like from root to leaves, you should be able to do that, but I don't think we are.
Go and predict something in the future, it can extrapolate that. But a random forest can't do that. There's no way, if you think about it, for a tree to be able to say, well, next month it would be higher still. So there's a few ways to deal with this, and we'll talk about it over the next couple of lessons. But one simple way is just to try to avoid using time variables as predictors if there's something else we could use that's going to give us a better, a kind of a stronger relationship that's actually going to work in the future.
Is that why the age feature that I tried yesterday for the Titanic thing didn't work, because it is time bound, and time bound things don't work great with random forests?
Sure. So in this case, what I wanted to do was to first of all figure out what's the difference between our validation set and our training set. Like if I understand the difference between our validation set and our training set, then that tells me what are the predictors which have a strong temporal component, and therefore they may be irrelevant by the time I get to the future time period. So I do something really interesting, which is I create a random forest where my dependent variable is it in the validation set? Right? So I've gone back and I've got my whole data frame with the training and validation all together, and I've created a new column called isValid, which I've set to 1, and then for all of the stuff in the training set, I set it to 0. Right? So I've got a new column which is just, is this in the validation set or not? And then I'm going to use that as my dependent variable and build a random forest. So this is a random forest not to predict price, to predict is this in the validation set or not. And so if your variables were not time dependent, then it shouldn't be possible to figure out if something's in the validation set or not. This is a great trick in Kaggle, right? Because in Kaggle, they often won't tell you whether the test set is a random sample or not. So you could put the test set and the training set together, create a new column called isTest, and see if you can predict it. If you can, you don't have a random sample, which means you have to come and figure out.
So on Kaggle, it's already split for you. And to put them together and look at the difference between test and train will probably help you.
How to create a validation set from it.
And we're not cheating because we're looking at it ourselves. We're not making our model who's working on the training set see the test set. Even if we're like here, he's training. Is he training on both of them? I don't think he is. I think he's just using X and Y.
Right? And so in this case, I can see I don't have a random sample because my validation set can be predicted with a 0.9999 R squared. And so then if I look at feature importance, the top thing is sales ID. And so this is really interesting. It tells us very clearly sales ID is not a random identifier, but probably it's something that's just set consecutively as time goes on. We just increase the sales ID. Sale elapsed, that was the number of days.
That's funny, saying ID goes up, because it's just like a serial number.
Since the first date in our data set, so not surprisingly, that also is a good predictor. Interestingly, machine ID, clearly each machine is being labeled with some consecutive identifier as well. And then there's a big, don't just look at the order, look at the value. So 0.7, 0.1, 0.07, 0.002. Okay, stop, right? These top three are hundreds of times more important than the rest, right? So let's next grab those top three, right? And we can then have a look at their values, both in the training set and in the validation set. And so we can see, for example, sales ID on average is, I've divided by 1,000, on average is 1.8 million in the training set and 5.8 million in the validation set, right? So you can see, just confirm, like, okay, they're very different. So let's drop them. Okay, so after I drop them, let's now see if I can predict whether something's in the validation set.
So we're dropping the important features and then seeing if it can be predicted.
Still can with 0.98 R squared. So once you remove some things, then other things can come to the front, and it now turns out, okay, that's not surprisingly age. Things that are old are more likely, I guess, to be in the validation set because earlier on in the training set they can't be old yet. Year made, same reason. So then we can try removing those as well. And so once, right? But if they're not important, then taking them out, there are some other non-time dependent variables that work just as well. That would be better, right? Because now I'm going to have a model that generalizes over time better. So here I'm just going to go ahead and go through each one of those features and drop each one at a time. Okay? Retrain a new random forest and print out the score. Okay, so before we do any of that, our score was 0.88 for our validation.
Okay.
Versus 0.89 OOB. And you can see here, when I remove sales ID, my score goes up. And this is like what we're hoping for. We've removed a time-dependent variable. There were other variables that could find similar relationships without the time dependency. So removing it caused our validation to go up. Our OOB didn't go up, right? Because this is genuinely statistically sizable time across time prediction. And here's how you can see it. So it's like, okay, we should remove sales ID for sure, right? But sale elapsed didn't get better. Okay, so we don't want that. Machine ID did get better. Went from 888 to 893. Right, so it's actually quite a bit better. Age got a bit better. Year made got...
Does it make sense to look at these features like ID? The model looks at it and it is important, but like year is important, but how is ID important? It's just the value that goes up. So isn't it supposed to be almost the same as, I don't know, age or year made, or I don't know, some date related thing?
Got worse. Sale day of year got a bit better. Okay, so now we can say, all right, let's get rid of the 3 where we know that getting rid of it actually made it better. Okay, and as a result, look at this. We're now up to 915. Okay, so we've got rid of 3 time-dependent things. And now, as expected, our validation is better than our OOB. Okay, so that was a super successful approach there, right? And so now we can check the feature importance. And let's go ahead and say, all right, that was pretty damn good. Let's now leave it for a while. So give it a...
Wait. Did we just have an issue? Should I put the issue counter? Because I needed to refresh my phone. There. Issue counter is 1, because I think it was an issue. Oh, you're good? What? That's fine. I still see it as an issue.
160 trees. Let it churn on it and see how that goes.
This is our final model, and 160 trees. That's a lot. Weren't we doing chat disconnected on your side? Yeah, it even shows.
Okay, and so as you can see, like we did all of our interpretation, all of our fine-tuning, basically with smaller models, subsets, and at the end we ran the whole thing. It actually still only took 16 seconds.
It's not weird because I know why it happened.
And so we've now got an RMSE of 0.21. Okay, so now we can check that against...
That's so good, because like it was 23, now it's 2.1.
It's Kaggle. Again, we can't... unfortunately, this older competition we're not allowed to enter anymore to see how we would have gone, so the best we can do is check whether it looks like we would have done well based on our validation set. So it should be in the right area. And yeah, based on that, we would have come first. Okay.
Wow.
So, I think this is an interesting series of steps, right? So you can go through the same series of steps in your Kaggle projects, and more importantly, your real-world projects. So one of the challenges is once you leave this learning environment, suddenly you're surrounded by people who they never have enough time. They always want you to be in a hurry. They're always telling you, do this and then do that. You need to find the time to step away, right, and go back, because this is a genuine real-world modeling process you can use. And it gives, when I say it gives world-class results, I mean it, right? Like this guy who won this, Listigos, sadly he's passed away, but he is the top Kaggle competitor of all time. Like he won, I believe, like dozens of competitions. So if we can get a score even within cooey of him, then we are doing really, really well. Okay, so let's take a 5-minute break, and we're going to come back and build our own random forest.
I am not gonna do that. Yeah, that's sad. I'm gonna do 2 things. Number 1, continue this extrapolation part. Number 2, maybe go to our mini competition and I wanted to do feature importance and see what else I can do, because I don't really know if I can use these things that he's doing, because honestly I may not understand well to replicate it, so why not try and see what I don't understand. did I run this? Yeah, reload, shut up. Should our counter go up or are we good? There was an error on my side. Extrapolation. Extrapolation. There. There. We're running with 40 estimators again. Looking. So here's what we're doing. From our data frame keep, we are adding. We are making a copy. And then we're saying, tell us, make it all valid, and if it is something about, I don't know what end-turn means honestly, but we're separating validation and training. And then we have procdf, y, and x, which is target. Now the target is valid. And then we have our random forest classifier. Here's x and y. And then we are printing the OOB score, and it is almost perfect. So our training and validation together are almost perfect, which is a good thing. Now you know your validation is good. And then here's the feature importance. Oddly, we have IDs at the top. And then we drop these. I mean, we put them somewhere, and then we say drop them. Well, no. Huh? Wait. Is not in... What do you mean, cell... Really? I mean, it's not here, you're right. We have cells year instead of cells elapsed. So that's different from his table. So in the training, the mean of sale ID validation is higher because it's newer data. We separated them by year. We did that on purpose. And then we're dropping these features and then training again to see if we made any difference. And the answer should be yes, there should be a difference. Okay, exactly the same as he got it. And then we're looking at feature importance again. We can see age, year made, sale day of year. Really? Is that also part of the feature importance? So instead of sale elapsed as he's done, we should do sale year, because our features are somewhat different. Okay, now we do the RF sample of 50k and then run again and then train again. And then we'll look at the score, and then we have this for loop for each feature. Now it's 88. For each feature, drop the feature and then train it based on the list of features here. I think we're looking at the importance of the feature in our sample of 50k. So for sale ID, if we drop sale ID, this is so cute. Okay, sale year is even lower. Machine ID. So I think what we're looking at is the difference between OOB score and R score, and if they're close, then that's bad? Is that what we were doing? So like there are parts where OOB score is better. Is that all? Yeah, cell day of year is the last one. So based on that, he's deleting cell ID, machine ID, and cell day of year. I understand cell ID and machine ID because I feel like having them is useless, because they're just IDs and there's nothing important about IDs. It's just a serial number. If your model is hanging on to IDs, then it means there's something wrong with your data. Wouldn't you say so? But cell day of year, ooh, it's really close to our OOB score. I think, yeah, the ones that are really close to our OOB score is the ones that we're dropping. He was expecting OOB score to be worse. Expecting, you mean? Oh. And then we're resetting it. And then we're dropping these. Let's see. Give me a second to drink some water.